What is molar heat capacity in thermodynamics? Imagine you're trying to warm up a large pot of soup. The amount of heat you need depends on how much soup there is, but also on how hot you want it to get. Now, think about doing this on a tiny scale, with individual molecules or moles of a substance. That's where molar heat capacity comes into play. It tells us how much heat energy is needed to raise the temperature of exactly 1 mole of a substance by 1 degree Celsius or 1 Kelvin. This property is measured in joules per mole per Kelvin. Joules are units of energy, and Kelvin is a temperature scale that starts at absolute zero. When we talk about molar heat capacity, we're focusing on the amount of heat needed for a specific amount of material, based on the number of molecules, rather than just mass or volume. This makes it very useful in chemistry and thermodynamics because it relates directly to the number of particles involved. To understand it better, think about heat capacity, which is the heat needed to raise the temperature of a given sample of a substance by 1 degree. If you divide that heat by the number of moles in the sample, you get the molar heat capacity. It's like breaking down the total heat needed into a per mole basis, giving us a clearer picture of how each mole of the substance responds to heat. Molar heat capacity can change depending on how heat is added. For example, heating a gas at constant pressure, where it can expand, requires more heat than heating it at constant volume, where it cannot expand. The molar heat capacity at constant pressure is usually higher because some of the heat goes into doing work to expand the gas, not just raising its temperature. It also depends on the physical state of the substance. Water's molar heat capacity is different when it is ice compared to when it is liquid water. During phase changes like melting or boiling, molar heat capacity isn't defined because the heat energy goes into changing the state, not just increasing the temperature. In practical terms, knowing the molar heat capacity helps predict how substances will react to heat during chemical reactions, in engines, or in natural processes. For example, engineers use it to calculate energy changes in engines or atmospheric phenomena involving gases. To find the molar heat capacity, you can use this simple formula: the heat added divided by the product of the number of moles and the temperature change. So, if you add a certain amount of heat to a substance and know how many moles are involved and how much the temperature increases, you can figure out its molar heat capacity. In summary, molar heat capacity is a key property that shows how much heat is needed to raise the temperature of 1 mole of a substance by 1 degree. It helps us understand how different materials absorb heat on a molecular level, making it a fundamental concept in thermodynamics and chemistry.